Hello again. This time, we will be talking about how to use the nth term of geometric sequence, specifically in solving for r, or the common ratio, or the number of terms, or even the nth term, or solving for the first term of a certain geometric sequence. And this is another lesson for Math 10. Okay, if you still remember, the nth term of geometric sequence is given by this formula. That is, nth term is equal to first term times the common ratio raised to the power of n minus 1, where this a sub n again, this is the nth term. Okay, then this a sub 1, that is the first term, or that will be read as first term. R, this is the common ratio, and n, this represents the number of terms. So we are going to bear this in mind, all of these terms, all of these things, so that we can really understand the nth term of a geometric sequence. Okay. So using this nth term of geometric sequence, we are going to try to find out the 15th term of the geometric sequence 2, 4, 8. Okay, again, we will be looking for the 15th term. So using this nth term of geometric sequence, we can solve that particular problem. Okay, given that our first term is 2, our common ratio is 2. How did we get 2? That is simply divide second term by the first term, which is 4 divided by 2, that is 2. Or divide third term by the second term, that's 8 divided by 4, and that is also 2. Now, our n here is 15. Why is it so? Since we are looking for the 15th term, so for this particular sequence, our terms are 15. So this 15th term is our last term. Therefore, there are 15 number of terms in our particular sequence. That is why our n here is 15. Now, applying the formula, okay, that one, or the nth term of geometric sequence, this one, we will substitute the given information. So our n again, that is this one, which is 15. Our first term is 2, this one. Our common ratio, r, that is also 2. So this r here will be replaced with 2. Then our n again, that is 15 minus 1. Okay, take note. We will be looking for the 15th term. After this, we will simplify. So simply copy this part here. This is what we are looking for. And then this 2 and 2, just simply copy that one first. Then we will have 15 minus 1 first. Simplify, and this is 14. Okay, using PEMDAS, we are going to execute or perform first the exponent. So 15 minus 1, and that is 14. Next, this one, 2 exponent 14, meaning you will multiply 2 14 times, and that is 2 times 2 times 2 up to 14 times. So we can get 16,384, and then multiplied it with 2. So 16,384 times 2, and that is equal to 32,768. So this is our 15th term. Therefore, the 15th term of our geometric sequence is 32,768. Okay. Second example. Find the common ratio r in a geometric sequence if the first term is 1/3 and the eighth term is 128 over 3. Okay, take note. We are going to look for the common ratio for this second problem. So these are the given informations. Our first term here is this one, which is 1/3. Our eighth term is 128 over 3. And our n is 8. Why is it 8? Because it is stated in our problem that our eighth term is 128 over 3. Therefore, our last term is 8th term. So there are obviously 8 terms or 8 number of terms in our particular problem here. So our n here is 8. And r, or the common ratio, is, this is what we are looking for, the common ratio. Okay. So for the second problem, our musing here is r. Previously, our musing there is the nth term. Okay, this time, we're going to look for the r. We will be using this nth term of geometric sequence. Okay. Next, we will substitute the given information. Our nth term here, this one nth term, or the last term of our sequence, and it is the eighth term, which is 128 over 3, is equal to, our first term here is equal to 1/3. So replace a sub 1 with 1/3. Then r, this is what we are looking for. Okay, r is unknown. And then n here is this one, which is 8. So we will replace n with 8 minus 1. Next, simplify this part first. So this will be, just simply copy this part, this one, and then r. Then 8 minus 1, and that is 7. Okay, next is, we are going to simplify here, this part. So, what happened here is that you are going to eliminate the numerical coefficient of r, this one. Okay, in which the numerical coefficient of r is 1/3. So, to eliminate 1/3, we will apply the multiplication property of equality. So we will multiply both sides by 3, which is the reciprocal of 1/3. So reciprocal of 1/3 is 3. So to eliminate 1/3, so that r here will remain, so we will multiply both sides by 3. So that's why this one here, you will multiply it with 3, and this part here, you will also multiply it with 3. Okay, so what will happen is that, okay, this one will be, this 128 is equal to r exponent 7. So, why is it so? This part here, multiply 3 by 128 over 3. So, this part here will be cancelled. This one, 3 and 3 will be cancelled. So, what will remain is 128 is equal to, this one, 1/3 times 3. This is also equal to 1. Or, what will remain is r exponent 7. Okay. Next is, you are going to think of a number that if you are going to make it as base, or if you are going to replace it with r exponent 7, or this part here, it will become 128. So what do you think is the number that if you are going to raise to the power of 7, it will become 128? Or simply look for the 7th root of 128, and that is 2. Okay, so here's 7th root of 2. That is 2 times 2 times 2 times up to 7 times. That is equal to 128. Okay, therefore, our r here is equal to 2. This one. Okay. Did you get this part here? So again, this part is, you are going to look for a number that if you are going to raise to the power of 7, it will give us 128. Or if it's hard for you to think what number, just simply get the 7th root of 128, and that is 2. Checking, that is 2 times 2, or multiply 2 7 times, and that is equal to 128. So therefore, our r is equal to 2. So for this particular problem, the common ratio is equal to 2. Okay, let's have this third example. What term is 2,916 in the geometric sequence 4, 12, and 36? Okay, we're asked what term is 2,916. So here, our first term is equal to 4. Our common ratio is 3. That is 12 divided by 4, that's 3. Or 36 divided by 12, that's also 3. Okay, so that's why our r is equal to 3. Now, our nth term, that is 2,916. So this is our last term, or the nth term of this particular sequence. And n, do we have n here? This is actually what we are looking for. Okay, the ordinal number of n, so that we can determine what term is 2,916. So now, applying this n term of geometric sequence again, so you can have this one. N term, substitute with 2,916. Our first term is equal to 4. And our common ratio, which is r, that is equal to 3. And n is unknown, so this is what we are looking for. Okay, next is, we are going to divide both sides by 4. Why? So that this 4 here will be eliminated. You cannot multiply 4 and 3 here, since 3 have an exponent. Okay, so first is, you are going to eliminate 4. Okay, or on this part, we can apply the multiplication property of equality by multiplying both sides by 1/4. Or simply, to make it easy, so simply you are going to divide both sides by 4, so that you can eliminate 4, and 3 exponent n minus 1 will remain. And then this part, 2,916 divided by 4, and that is 729. On this side, since 4 here is equal to 1, 4 divided by 4, that is equal to 1, or this will be eliminated. So this 3 exponent n minus 1 will remain here. Okay, next, what are we going to do? So this will be, okay, this is what will happen next. Just simply copy this part, 3 n minus, exponent n minus 1. For this part, you are going to express this particular number with a base 3. And we are going to think of a number that if you are going to make that number as your exponent for 3, it will give us 729. So what do you think will be our exponent here? Exponent of 3, so that we can have 729. Okay, and that is, okay, 6. Why is it 6? Since 3 multiplied 6 times, that's 3 times 3 times 3 times 3, 6 times, we can have 729. Okay, so this question mark here will be replaced with 6, since 3 exponent 6 is equal to 729. Okay, since we have equal bases, we have base 3 here, we also have base 3 here, we can equate 6 is equal to n minus 1, since we have equal bases here. This one. Since the bases are equal, so we can also equate 6 and then n minus 1. Transpose. Okay, this will become n is equal to this one. Transpose negative 1, this will become plus 1. 6 plus 1 is equal to 7. Or applying the addition property of equality. This is negative 1, so you are going to add here positive 1 on this side. So negative 1 plus 1, it will become 0. So n here will remain. Since you add 1 here, you will also add 1 on 6. So 6 plus 1, and that is 7. Okay. So in this part, we will apply the addition property of equality. So therefore, we can have n is equal to 7. So are we done for this problem? Is this the final answer? No, it's not. We are asked to find what term is 2,916. So our final answer will be this one. Since our n is 7, we can say, therefore, 2,916 is the 7th term. So this is now your final answer. So we can say that this number here, 2,916, this term here is our 7th term, since our n is 7. So this is our 7th term. Okay, hope you understand this part. How about this fourth example? Okay, we'll have number 4. Okay, for number 4, you can have find the first term in a geometric sequence whose r is 1/2 and 10th term is 9/32. So this time we are looking for the first term. Okay, previously for our first example, we are looking for the nth term. Second example, we are looking for the common ratio. Third example, we are looking for the n. And for this particular problem here, we are looking for the first term. Okay, we are given that our common ratio is 1/2 and our 10th term is 9/32. So again, we will apply the nth term of our geometric sequence. So that's it. This one. Our nth term is, or the last term is 9/32. So replace a sub n with 9/32. Which is equal to our first term. This is unknown. This is what we are looking for this particular problem. And our r, our common ratio is 1/2. So replace r with 1/2. And our n is equal to 10. How did we know that it's 10? Since our 9/32 is the 10th term. This is our last term for this sequence. Therefore, there are 10 terms. Okay, so our n here is 10. Okay, this part, you are going to simplify this part first. So this will become 9. Since 10 minus 1, and that is 9. Okay, what will happen next? This part. 1/2 exponent 9. So this will become 1/512. How did we get 1/512? That is simply multiplying 1/2 9 times. Raise 1 to the power of 9, that's 1. 1 exponent 9, or 1 times 1 times 1, that's also 1. And then 2, this one here, 2 raised to the power of 9. So 2 multiply 9 times. So 2 times 2 times 2 times 2, 9 times, and that is 512. So therefore, this 1/2 raised to the power of 9 is equal to 1 over 512. Okay, copy that first term. Now, to solve for the first term, you are going to, okay, we have this one. Multiply first term with 1. Okay, so first term times 1, that is obviously first term. Next, what will happen? Okay, this one, we are going to cross multiply. Okay, we will have it here. 32 times first term, that is 32 first term. Okay, this one. 512 times 9, this part here. 9 times 512, and that is 4,608. This one here, this is 32 times first term. So that is why we have 32 a sub 1. Next, we are going to look for the first term. So we are going to eliminate the numerical coefficient of a sub 1, which is 32. Now, to eliminate that one, we will divide both sides by 32 so that this 32 here will be eliminated. Or simply this part, you are going to apply the multiplication property of equality, in which you are going to multiply both sides with 1 over 32. To make it easy, simply divide both sides by the numerical coefficient of a sub 1, which is 32. So what will happen is 32 is eliminated now. So what will remain on this side is only the first term. Okay. And 4,608 divided by 32, and that is 144. A here, a sub 1 here will remain. Therefore, we can say that the first term is equal to 144. So the first term of our geometric sequence is 144. Okay. Thank you. I hope you learned something from this time. This is Teacher Con again. Have a nice day.